In the late 1940s, the United States military faced a terrifying geographic reality. The jet age was dawning, but jet engines were thirsty, inefficient, and lacked the range for intercontinental flight. To bridge the gap, the engineers at Convair were tasked with building a machine that defied the traditional laws of scale. The result was the B-36 Peacemaker, an aircraft so massive it was nicknamed the aluminum overcast. Its 230-foot wingspan wasn't just a record breaker, it was a structural necessity to lift 411,000 pounds of metal, fuel, and payload into the stratosphere. The heart of this mechanical giant lay in its unconventional propulsion system, 6 Pratt & Whitney R4360 Wasp Major engines. These were not your standard aircraft engines. They were 28-cylinder Corncobs, the most complex and powerful piston engines ever mass-produced. But the true engineering deviation was their placement. Convair opted for a pusher configuration, mounting the engines on the rear of the wings with the propellers facing backward. This wasn't a stylistic choice, it was a calculated aerodynamic gamble. By placing the engines at the rear, the engineers ensured that the air flowing over the massive wings remained clean and laminar, undisturbed by propeller wash. This maximized lift and allowed the B-36 to reach altitudes of over 40,000 feet, a height where contemporary Soviet interceptors struggled to find enough air to breathe. However, this pusher design created a legendary thermal nightmare. Because the engines were behind the wing, they were shielded from the natural ram air cooling that usually keeps a radial engine from melting. The engineers had to design a complex internal ducting system just to keep the rear-facing carburetors from icing over in the high-altitude cold, while simultaneously preventing the cylinders from overheating. It was a delicate, high-tension balance of fluid dynamics and thermodynamics. The B-36 wasn't just a plane, it was a flying laboratory of piston-driven limits, proving that if you wanted to dominate the globe, you had to first dominate the very air you were flying through. As the 1950s progressed, the rapid advancement of Soviet jet interceptors threatened to make the B-36 piston-driven speed obsolete. The aircraft was a massive target, and while its altitude was impressive, its top speed of roughly 346 miles per hour was no longer enough to ensure survival in a contested airspace. The solution was an ambitious engineering retrofit, the addition of 4 General Electric J-47 GE-19 turbojets. Mounted in paired pods near the wingtips, these engines transformed the B-36 into one of the few 10-engine aircraft in history. This created a rare mechanical hybrid. The crew now operated under the mantra 6 Turnin and 4 Burnin. The J-47 jets were not designed for the entire duration of the flight. Their primary function was to provide the massive thrust required for short-field takeoffs and to increase the dash speed during the final run toward a target. With all 10 engines engaged, the B-36 could push its airspeed over 400 miles per hour and climb to an even more staggering 47,000 feet, placing it well above the effective ceiling of many early-generation jet fighters. However, integrating jet turbines with massive radial piston engines presented a significant logistical challenge for the flight engineers. The R4360 radial engines burned high-octane avgas, while the J-47 turbojets were designed for JP4 jet fuel. To avoid the weight and complexity of separate plumbing and tanks, the engineers designed the J-47s on the B-36 to be modified to burn the same avgas used by the piston engines. This meant the flight engineer had to monitor a staggering array of instrumentation, over 80 different gauges just for the engines alone.
They had to manage the manifold pressure of the 6 reciprocating engines while simultaneously monitoring the exhaust gas temperatures, EGT, of the 4 jets. This hybrid configuration represented the absolute limit of analog flight engineering. It was a bridge between 2 eras of aviation, utilizing every available pound of thrust to keep the world's largest bomber relevant in a rapidly accelerating theater of war.
The sheer physical dimensions of the B-36 Peacemaker created a problem never before seen in aviation: how to manage a crew of 15 across a fuselage that stretched 162 feet. Unlike smaller bombers, where the crew was grouped in a single cockpit, the B-36 was divided into 2 distinct pressurized compartments, the forward flight deck and the aft crew station, separated by 4 massive, unpressurized bomb bays. To solve the challenge of moving personnel between these 2 areas during high-altitude, long-duration missions, Convair engineers designed a pressurized communication tunnel. This was a cylindrical tube, only 25 inches in diameter, running 85 feet through the center of the aircraft's spine. Because the tunnel was too narrow for a person to walk through comfortably, it utilized a specialized 4-wheeled trolley. A crew member would lie flat on their back on the trolley and pull themselves along an overhead cable, effectively ferrying across the cavernous interior of the bomber. This tunnel was the bloodline of missions that could last over 40 hours. The aft compartment contained a galley and 6 bunks, allowing the crew to rotate between duty and rest. Without this pressurized artery, the fatigue of managing 10 engines and a complex radar navigation suite would have been insurmountable. The B-36 functioned less like a traditional aircraft and more like a flying naval vessel, requiring constant communication and movement between specialized stations. The mechanical legacy of the B-36 ended in 1959, replaced by the all-jet B-52 Stratofortress. It was a machine built at the absolute edge of what was possible with metal and reciprocating engines. While it never dropped a nuclear weapon in combat, its success was measured in its deterrent effect. It was a masterpiece of piston-era engineering that provided the United States with its first true intercontinental reach, proving that through sheer scale and mechanical integration, an aircraft could dominate the globe without ever firing a shot.